So you see this board and you think, hey, I know that. It's an Arduino Uno. And you'd be kind of right. But see that little Q on the end? Yeah, that changes everything. Today, we're doing a deep dive into the Arduino Uno Q, a device that stuffs the power of a full computer into that classic Arduino shape. I mean, look at it. It's got that classic, iconic shape we all know and love. But you really can't judge this book by its cover. What's hiding under the hood here is a massive, massive leap forward in capability, and that's what we're going to unpack. You know, DroneBot Workshop put it perfectly. The Uno Q isn't just another update, it's a hybrid. So what does that mean? It means you've got the raw processing power of a Linux computer for the heavy thinking and the super fast reflexes of a microcontroller for precise, real-world actions. That combo is the secret sauce here. All right, so here's the game plan. We're going to cover why this isn't just another Uno. Then we'll get into its dual brain setup. After that, we'll check out the totally new way you code for this thing. I'll walk you through getting started, and we'll look at some amazing projects before we wrap it all up with a final verdict. Sound good? All right, let's dive right in. Section 1. This is not just another Uno. This board is a huge signal of a whole new direction for the Arduino platform. So what's with the Q? Well, that's a pretty big clue right there. It stands for Qualcomm. This board is basically the first big thing to come out of their partnership with Arduino, and it shows they're aiming for much more powerful devices, ones that can handle really complex jobs like AI, but without losing that hands-on direct control that we all love about Arduino. Okay, so that brings us to section 2, and this is where it gets really interesting. Let's talk about the dual brain board and figure out this whole MPU plus MCU thing. The best way to get your head around this board is to think of it as having two brains working together. See, on the top here, that's the Qualcomm microprocessor, the MPU. Let's call that the thinking brain. Then, if we flip it over, on the bottom, you've got the STM32 microcontroller, the MCU. That's the doing brain. So, how do they split up the work? It's actually a brilliant setup. The microprocessor, the MPU, that's the powerhouse. It's a quad-core beast running a full version of Debian Linux. It's designed for the heavy lifting. We're talking AI, running web servers, handling graphics, you name it. Meanwhile, the microcontroller, the MCU, it sticks to what Arduinos have always been amazing at. Super precise, real-time control of those GPIO pins, reading sensors instantly, and anything where timing is absolutely everything. Okay, so you've got two brains. How in the world do they talk to each other? That's where something called the Arduino bridge comes in. Just think of it like a super efficient translator. It's a layer of software that lets the big Linux brains send commands and get info from the speedy microcontroller brain so they can cooperate perfectly on one project. And you can actually see this division of labor right on the board itself. Those familiar Arduino headers? They're all controlled by the 3.3-volt MCU, so all your old shields and parts should work just fine. But these new high-speed connectors for things like cameras and displays, those are wired directly to the more powerful 1.8-volt MPU. It's a really clear and smart way to separate the duties. Now, with all this new hardware, you're probably guessing there's a new way to code for it. And you'd be right. So for Section 3, let's talk about coding with apps and bricks and get to know the new software environment, Arduino AppLab. So say goodbye to the old Arduino IDE, at least for this board. The new kid on the block is Arduino AppLab. This is your one-stop shop. It's where you'll write your classic C++ Arduino sketches for the microcontroller and your Python scripts for the Linux processor, all in one project. It handles all that tricky communication between the two behind the scenes. And get this, you can run it on your PC, or you can run it directly on the Uno Q itself. How cool is that? Okay, inside AppLab, you need to know two new terms, apps and bricks. An app is basically your whole project. It's the container that holds your Python code, your C++ sketch, and all the settings. Now, bricks are the real game changer. Think of them like code Legos. Need a web server? Boom, drop in the web server brick. Want to do some AI object detection? Just snap in the camera brick and an AI brick. They're these pre-made modules that let you add seriously complex features in no time. Okay, but let's be real for a second. This is a huge leap from the simple plug-it-in, upload, and go world of a classic Arduino. And we're not the only ones who think so. A user on the Arduino forum put it really well. They said it's a slow, complex, multi-layer process, and that for all practical purposes, you pretty much need a Wi-Fi connection to get this thing up and running. So yeah, it's powerful, but there is a bit of a learning curve here. So keeping that in mind, let's jump into Section 4, and I'll walk you through your first 5 minutes. We'll make this as painless as possible with a quick step-by-step guide to get you started. All right, getting started is basically a 4-step process. First step, you'll need to download the AppLab software and a little command line tool called the Flasher. Step 2, you need to put the board in flash mode, which is super simple. You just use a jumper wire on 2 little pins. Third, you'll open up a terminal and run one simple command to flash the latest OS and firmware onto the board. This part takes a little patience. And finally, step 4, take the jumper off, plug the board into your computer, and fire up AppLab to finish the setup. That's it. Okay, once all that setup is done, now the real fun begins. Let's get into section 5, from blinking to thinking, and see what this board can actually do. You know, the perfect way to really get this whole dual brain thing is to look at the good old blink example. On the Uno Q, the microcontroller part, the MCU, does exactly what you'd expect. It blinks an LED. Simple. But here's the magic. At the exact same time, the microprocessor, the MPU, is running a Python script that's logging every single blink and serving up a live web page that shows you the count in real time. It's such a simple idea, but it perfectly shows how these two parts collaborate. And believe me, it gets way more advanced than just blinking an LED. You can build projects like a weather station that pulls live data from the internet and shows animated weather icons on the little LED matrix. Or there's a web-based painter for that same matrix. You can even get into AI with an object hunting game that uses a camera, or make a digital ferryman. There's even a little endless runner game. These examples really show off the incredible range of this board, from IoT and AI all the way to interactive art. Which brings us, finally, to section 6, the final verdict. So with all this power, and yeah, a bit of complexity, is the Arduino Uno Q actually the right board for you? Let's break it down. All right, first things first, power consumption. This is always a big question with single-board computers, but check this out. Thanks to some awesome real-world testing from a forum user named Guy, we can see the Uno Q is actually super efficient. At idle, it's sipping just half a watt. And even when you push it to its absolute max, it's only pulling around 3.5 watts. That's pretty impressive. So you might be wondering, if it's so efficient, why does Arduino tell you to get a 15-watt power supply? Well, that's all about planning for the future. That 15 watts gives you enough juice to power the board, plus whatever power-hungry gadgets you might hook up to it. Think cameras, big displays, motors, you name it. The board itself doesn't need it, but your whole project might. Okay, so this is the big question for a lot of people. Uno R4 or this new Uno Q? Here's the simplest way to think about it. The R4 is a pure, classic-style microcontroller. It's fantastic for hardware-focused stuff, learning the ropes, and anything needing rock-solid real-time control. The Uno Q, on the other hand, is a completely different animal. It's a full-on computer plus a microcontroller. It's built for big, complex jobs like AI, processing video, running web applications, and advanced IoT. It also has way better connectivity baked right in. They're not really competing with each other. They're different tools for totally different types of projects. When you get right down to it, the Arduino Uno Q is something special. It takes two incredibly powerful but very different worlds, the world of high-level Linux computing and the world of precise real-time control, and puts them together on one single, familiar-looking board. It's a bridge between software and the physical world. So really, the final question isn't just about whether you should buy one. It's this: with the power of Linux and the precision of a microcontroller at your fingertips, what are you going to create?